A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the ENCLAPS channel. Ring the bell button and open success. It's that easy.
Hi. In the previous class, we have studied how electricity is generated. Electricity is produced in larger industrial scales in systems like dams using huge generators. This electricity is transmitted through electric poles using line wires. This is called the power transmission process of electricity. Have you ever noticed an instrument like this? Yes, this is called a transformer. Using a transformer, it is possible to change the amount of current and can transmit the current to a longer distance. Now, shall we take a look at the working of the transformer? Let's do an activity. Here, you can see a soft iron core is wounded with two sets of insulated copper wire. Connect the first copper wire to a cell and the other to a galvanometer as shown here. When the switch is turned on, we can observe a deflection in the galvanometer. The needle deflects towards one direction and comes back to the original state. Galvanometer needle remains undeflected when the switch is on. When the switch is turned off, the galvanometer needle deflects in the opposite direction. What may be the reason behind this? Let's take a look through this. Here, we can see a 6-volt bulb and a transformer which gives 6-volt output and two solenoids. One solenoid is connected to the circuit. When the switch is on, the current flows from the transformer to the solenoid to bulb and then goes back to the transformer. The coil to which we give electricity is called the primary coil. The coil next to the primary coil is called the secondary coil. Here, the bulb is shorted to get enough electricity to the solenoid. AC is given to the circuit. It changes its direction 100 times in a second. As AC passes through the solenoid, it acts as an electromagnet which changes its polarity 100 times per second. So, the electric field lines changes its direction continuously. As a result, a change of flux happens in the secondary coil and hence an EMF is induced there. Even though an EMF is induced in the secondary coil, the LEDs connected to them do not glow. This is because the EMF induced there is not sufficient to glow the LEDs. So, we have to increase the amount of induced EMF. For that, we introduce soft iron into the core of both the solenoids. Now, the iron core also acts as an electromagnet. So, the total number of field lines increases. The change in flux in the secondary coil increases and hence more EMF is induced in the secondary coil. As a result, the LEDs which are connected to the secondary coil glow. Here you can see that there is no physical connection between the primary and the secondary coils. We are giving electricity only to the primary coil, but the LEDs in the secondary coil glows. This phenomenon is called mutual induction. Here you can observe that as the distance between the primary and secondary coil increases, the change of flux decreases. The amount of EMF induced also reduces and hence the intensity of LEDs decreases. Whenever there is a change in current in the primary coil, that is, when the switch is turned on, when the switch is turned off or AC is passing, an EMF is induced in the secondary coil. This is known as mutual induction. This is the working principle of the transformer we talked about earlier. That is, a transformer works based on mutual induction. Using a transformer, it is possible to change the amount of current and then transmit through long distances. That is, there are two types of transformers: step-up transformers and step-down transformers. Step-up is the name given to transformers that convert small voltages into large ones. In step-up transformers, voltage increases. Transformers that convert large voltages to small ones are called step-down transformers. Voltage is decreased here. Now, let's look at the similarities and differences between these. Here you can see two pairs of coil on both sides of an iron core. AC is provided to the coils on the left side. So, the primary coils will be the coils seen on the left side in both places here. The primary coil is the coil to which we give current. The other is the secondary coil which gets the current. When the switch is turned on, there is a constant change in flux. The flux variation in the coil is constant in the opposite directions. Hence, AC is induced in both coils. That is, a flux change occurred in the primary coil and the secondary coil. It induces a EMF in both coils. Here, NP is the number of turns in the primary. Similarly, NS is the number of turns in the secondary. Voltage in primary is denoted as VP and voltage in secondary as Vs. Considering the step-up transformer, the voltage we supply in the primary will be less and the voltage in the secondary will be higher. That is, Vs greater than Vp. The voltage at the secondary is higher than the voltage at the primary. Also, the number of turns and thickness of the primary and secondary windings of the step-up transformer and the step-down transformer vary. There is an easy way to remember this. Whenever the voltage is higher, there will be more turns. As the number of turns increases, the thickness of the wire decreases. So from here, we can clearly say that the number of turns in the secondary is greater than the number of turns in the primary. This is because the voltage is higher in the secondary in step-up transformers. Then NS greater than NP. Now, in the case of the step-down transformer, it is opposite. In step-down transformers, NP greater than NS and Vp greater than Vs. The higher the voltage applied to the primary of the step-down transformer, the lower will be the voltage across the secondary. Also, the voltage in the primary will be higher and the voltage in the secondary will be lower. Vp greater than Vs. The voltage Vp will be higher in the primary. Therefore, the greater the number of turns in the primary, the thinner will be the coil. As the number of turns decreases, the voltage will be less. NP greater than NS. Now, let's examine the induced EMF. If the EMF induced in a single turn in a secondary is taken as E, the total induced EMF will be Vs is equal to Ns into E. Likewise, the total EMF in a primary coil will be Vp is equal to Np into E. We know that the thickness of turns in a transformer is not a constant, but the power of a transformer in a working condition remains constant. So, from the equation of power, that is P is equal to V into I, we can conclude that in a transformer, voltage and current are inversely proportional. That is, if voltage increases, current decreases and vice versa. So, in a step-up transformer, Vs greater than Vp and Ip greater than Is. For a step-down transformer, Vp greater than Vs and Is greater than Ip. Amount of current is higher in the primary of the step-up transformer and the secondary of the step-down transformer, and hence the heat will also be higher. Due to this, thick wires are used as coils here. Why is it so? It is to reduce the heat. Resistance will be less in a thick coil. As the resistance decreases, heat will also decrease. As we mentioned earlier, the power in the primary and the secondary coils of a transformer will be a constant. That is, P is equal to V into I. So, we can write Vp into Ip is equal to Vs into Is. Like this, one more equation is there. Ns divided by Np is equal to Vs divided by Vp. On combining these two equations, we get Ns divided by Np is equal to Vs divided by Vp is equal to Ip divided by Is. This one is called the transformer equation. Let me ask you a question. What happens if DC is given instead of AC in the primary? Let's see. If DC is supplied to the primary, the direction and magnitude of the current do not change. This causes a static flux to form around the coil. Therefore, there is no change in the magnetic flux around the coil. That is why the transformer does not work in DC. Is it now clear that the function of transformer is mutual induction? So, in this session, we studied what mutual induction is, the working and properties of transformers, and the equation of transformers.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ എൻക്ലാപ്സ് ദ ലേണിംഗ് ആപ്പ്.